In recent years, there has been growing interest in exploring the impact of hybrid collaborative interfaces for distributed teams. In such scenarios, teams involve both co-located and remote people undertaking synchronous and asynchronous tasks using different technologies. However, when we think of these situations, they commonly involve screen-mediated approaches such as large shared displays or private workstations. This impacts the types of collaborative activities that can be effectively conducted. Additionally, screen-based approaches make it difficult to maintain group awareness, while also presenting additional barriers for remote participants to feel engaged. Recently, there has been numerous examples of using mixed reality technologies to support remote collaborative experiences using virtual environments and assets. As opposed to screen-based approaches, mixed reality allows its user the freedom to explore the collaborative environment, updating their viewpoint free from any dedicated camera. It also allows varying 3D representations of remote collaborators as avatars, allowing for the interaction space to extend beyond the bounds of a traditional screen. However, while virtual environments offer a medium for grounded communication, the ability to share physical artifacts is limited. What do you do if you need to collaborate around a physical area with physical props? In this work, we present Volumetric Hybrid Workspaces, a volumetric telepresence mixed reality platform to support interactions between partially distributed teams. Volumetric Hybrid Workspaces builds on our past work on volumetric telepresence. A site is enabled with several depth cameras which capture people and objects moving throughout the environment. In real time, the captured data is transmitted over an enterprise network where the data is reconstructed and rendered into the remote space. This process integrates people, objects, and environments, both virtual and physical, into one hybrid workspace. Volumetric Hybrid Workspaces duplicates this process for both sites, creating a bidirectional volumetric telepresence experience for its contained users. In the left video, we have a single user organizing paper on a table. We can see them gesturing at sheets of paper, demonstrating that they are currently in conversation with someone. On the right video, we have another room involving two people. Looking at the two rooms individually, we have two independent physical work areas. But how can we combine both work areas into one seamless interaction space? Volumetric Hybrid Workspaces aligns both rooms around a common work area, in this case, the central table. Using volumetric capture and reconstruction, all physical props from both sites are captured and transmitted to the alternate site. As you can see, collaborators in both rooms are spatially aware of each other's actions, positioning, and gesturing. Traditionally, for the co-located users, they can rely on non-verbal cues such as head gaze, body gestures, object interactions, and their associated context of their actions to support workspace awareness. This can be recognized in their ability to organize cards onto the table. However, looking at the two videos, you can see that this behavior is apparent across rooms. No longer are there two separate sites, but one combined hybrid workspace. More details on the technical implementation can be found in our paper. An artifact of the volumetric hybrid workspace approach is the classification of hybrid representations of objects. Physical objects that exist in the same physical environment as the collaborator, volumetric renderings of physical objects that exist in the remote environment, and virtual objects that exist in the virtual environment without any physical representation. The following footage is captured from each collaborator's HoloLens 2 head-mounted display and gives an indication to the experience of each participant during a collaborative exercise.
We have
This
shark.
one we'll put a shark.
Yeah, shark, probably, yeah.
Yeah, shark's a water animal. Yeah, we got penguin as well.
Penguin. Do you want to?
Penguin. We'll put penguin.
Do you want to show?
We undertook a user study to explore the impact of volumetric hybrid workspaces on a 3-user partially distributed collaboration. We set up 2 soundproof physical meeting rooms measuring 4.2 meters by 3.5 meters. Each contained a 3-camera volumetric capture rig. Each room was connected via our university enterprise network. Both rooms contained a one-way mirror along one side, allowing for observations to be made throughout the study. In the middle of each room, a table was positioned inside the space. This was the feature that was used to create the hybrid workspace. The study evaluated the impact of volumetric telepresence on communication, negotiation, organization, and content creation across the three formats of objects: physical, virtual, and volumetric. The study aims to address two research questions in the context of a volumetric telepresence mixed reality system. How do communication and negotiation techniques differ across remote and co-located users? And what are the differences in perception, interaction, and engagement across the three formats of objects used in collaboration tasks? The study involved a between-subjects design, co-located versus remote, and a within-subjects design across the three object formats through a combination of collaborative tasks. All three participants were provided with a HoloLens 2 optical see-through head-mounted display. This allowed each user to see their local environment using their natural vision, whilst also seeing users from the other room as volumetric renderings. We conducted 6 sessions, each with groups of 3. 2 users were co-located together in room 1. 1 user was located by themselves in room 2. Co-located users interacted with each other through physical objects. Users across both rooms interacted with each other through volumetric representations of the physical objects. Participants completed 7 tasks involving the sorting and grouping of cards placed on the table. For all tasks, participants were asked to work together as a team to achieve the final goal. Additionally, it was made clear that they were not being measured on time, but on the quality of the outcome. The 4 types of tasks undertaken by our participants were a training task, a hybrid task, a control task, and finally, a negotiation task. Training was designed for users to familiarize themselves with the system, the hand-tracking interactions, and with one another. For the remaining 3 types of tasks, physical and virtual cards were provided to groups with printed animal names. For each task, groups were required to group names by a provided challenge, such as alphabetically or by number of limbs. For hybrid tasks, paper cards were divided equally between each room. For control tasks, paper cards were provided to one room only. The alternate room would collaborate through volumetric cards only. For negotiation, paper cards were provided along with blank cards. The task introduced the creation of new content. Participants were asked to write their own animal names down to fulfill the required challenge. Our data included 15 hours of video recordings and audio recordings from interviews and training studies, as well as researcher observations across all sessions. From our analysis, we identified 4 themes: respecting each other's space, collaborating in the same physical environment, interactions across the scene, and strategies to support coordination. For more in-depth analysis and discussion on our findings, I would recommend viewers to read our paper. For this presentation, I'll touch on 3 interesting insights. Proxemic behaviors were in the most part respected by our participants. This observation is incongruent with the findings in related work, where participants would make a conscious effort to respect the collaborator's space. For volumetric hybrid workspaces, even though participants were in separate rooms, many participants commented on being aware of their presence. As described by one participant, "We all respected each other's space, like even the virtual, and the real ones even didn't have to do it. We had this inherent sense of, okay, that's their space. I'm going to move immediately." In the images, you can see an instance where a participant becomes aware of an immediate proximity to a remote participant. Their reaction demonstrates the startling discovery as they throw their hands up and take a step backwards. Participants did not alter their collaborative behaviors towards co-located and remote users. Contrary to prior work on partially distributed teams, volumetric hybrid workspaces exhibited strong tight couplings between remote locations previously highlighted as being only possible with co-locateds. Throughout the experience, physical objects were gestured towards and manipulated to update their volumetric representations. The experience of volumetric hybrid workspaces resulted in the perception that all users coexisted within the one singular workspace. When all participants were asked how many tables were in the exercise, everyone responded with the answer of 1. Strategies to exist in coordination emerged throughout the study sessions. Several participants highlighted the importance of ensuring everyone felt included. The entire workspace became a group territory, with all members of the partially distributed team utilizing the space as if they were co-located. Verbal communication was the dominant source of coordination. However, body language and movement also played an important role. Participants were observed gesturing towards physical and virtual objects, holding physical objects up to other fellow participants to read, and manipulating the local environment to maintain cohesion between remote sites. As highlighted in the provided participant quote, many participants use body movements as a cue to undertake an action, in similar vein to when co-located. Volumetric hybrid workspaces effectively created a shared space, with our findings demonstrating the successful integration of remote spaces. Our participants were able to effectively use proxemics and deixis to support negotiation and undertake the collaborative activities. Based on our developed approach, there are numerous future directions afforded by the results from this work. The approach used in this work resulted in a strong working relationship between our groups. Future work will broaden the possible activities for bidirectional mixed reality collaborations between partially distributed teams. Such activities are likely to include dynamic tasks that require participants to shift between tight and loose couplings, allowing for a focus on coupling styles. Activities that allow a deeper exploration of the interplay between physical, volumetric, and virtual interactions, and extending the definition of a hybrid workspace to include additional areas of interest, incorporating virtual reality, or considering the application of incongruent spaces. Please refer to our paper for more details or contact us if you have any questions. Thanks for watching.